Hello, everyone. As some of my followers know, I stepped away from math education in October. The I was not. I had taught at a virtual academy the year before, and going back to in person, I was not prepared for the 90-minute classes I was placed in, and so. But there were other reasons as well about just some philosophical um, differences or criticisms I have of math education. And that's what I wanted to go over today. So I have a presentation here just about all the problems with math education. So a lot of people have heard of new math, and that was actually not what it turned into at first. So at first, it was led by this man, Caleb Gattegno, and he was using these rods and blocks to help students visualize numbers or um, experience numbers perceptually instead of just symbolically. And so that was the key. He wanted numbers to be grounded in the perception of these elementary school kids he was working with. So what it became, unfortunately, was problems like this where so Gattegno actually did agree with this idea that um, algebraic relationships could be sometimes simpler than arithmetic, than memorizing your times tables, for instance. But he wanted it to be perceptual, based on touching the rods and the blocks. And unfortunately, schools kept that idea and got rid of the perceptual basis and put in these symbols instead. So it's just absurd, I think, to have these algebraic type problems in first and second grade, but that's what's currently happening. And there's really no reason to even use an equal sign in teaching math. There's plenty of interesting things you can teach about math without introducing the equal sign. You don't really need that till you start doing algebra. So um, yeah, I think that's one of my. I was actually shocked to learn that first and second graders are doing problems like this. Mhm. So Jo Boaler is a. I agree with a lot of her suggestions for math teachers, and yeah, she encourages multiple solution paths and visual reasoning. And so I pretty much agree with everything she says. Unfortunately, her work has been extremely politicized. So she was coming up in California about 20 years ago, right when California was becoming known as a very liberal state. And so it was kind of guilt by association to some extent. And um, there's been all these crazy criticisms of her that are completely over the top. And so that's been very unfortunate. So, and a lot of those criticisms are made by people who believe that we should return to a more rigorous approach to teaching math. And there's something to be said to that, mainly that math is uniquely complex. It is, I think, there's a complexity of math that you don't get from learning about history or literature, and because those things can be complicated, but and it's easy to confuse those two things, something that's complicated and something that's complex. Something that's complicated, you can still understand it by breaking it down, and if you break it down far enough, you can still predict exactly what the complicated things. Well, you can still come up with very precise explanations for everything. If something's complex, that's when no matter how far you break it down, you're not going to be able to predict what comes next. So another good example is that working on a car's engine, all the mechanical parts of the engine are very complicated, but your mechanic, he knows how to break it all down and repair anything that goes wrong with it. The electrical system in the car, if one of the lights is having trouble, that's a whole different thing, because that's a lot more complex. It's hard to break down exactly where the problem is with the electrical system, because it could be in a little fault in anywhere in the wiring. So the electrical system is complex, and it's very hard to isolate exactly where the problem is. And so teaching math differently from other subjects, saying that, well, with math, we got to teach it in this old school way, that actually, I think, implicitly communicates that that difference that math has from other subjects. So, then there's some other teaching approaches that have various degrees of effectiveness and that I think are good. And I think it's good to have this associate math problems to some sort of narrative that kind of makes students curious and interested in it. And then the big problem, though, with math education today is it's just not economically useful as it was 100 years ago to learn how to solve algebra equations. So the word computer 100 years ago actually meant someone who gets paid the equivalent of $40,000 a year to solve math equations all day. So that's what the word computer originally meant, and we're still training people to become computers in math class, basically, even though that job no longer exists. And so that's kind of what Conrad Wolfram's criticism is, and he has this really good quote. It's easy to get funding to slightly increase students' test scores, but that's not the issue with math. The issue with math education today is that the whole subject has kind of gone off kilter. Like, no one really understands what the purpose of learning it is, because it's not economically useful like it used to be. So the solution is what I call creative mathematics, and the purpose of that is to develop intuition about information. So that fixes all these current problems with math, I think. And it's based on this Ohio State professor, Angus Fletcher, his theory of creativity. And so that's the outline there. Basically, he sees intuition as very important in the creative process. It's what triggers creativity, is when you notice an exception to how the world is working. For instance, if I like to ask, who creates more money, the government or banks? Most Americans are taught that the government prints the money, and so they would say the government, but it's actually the banks make more money than the government. So then you talk about different explanations for that. How can banks create money without the ability to print currency? And then you finally find the right story to explain it, and then you have a better, more accurate model for how the world works. And then the other thing I think is important is to link math to science as well, because it has a lot of fascinating narratives within science. So the purpose of math in this approach is to develop intuition about information. So information is defined as a meaningful fact about a pattern or system. And then exceptions are a special kind of information that does not fit the current pattern. So information is how you, was what builds the pattern, is how you understand how you see the world working. And then exceptions are what destabilizes that pattern. And so the whole point is that mistakes are just exceptions to your current model. When you make a mistake in math, that's not a bad thing. It just means that you need to update your model. So either that or you misunderstood the question, which happens more often than a lot of students realize. They just read they didn't understand the question, or they missed one of the words in the question. So when you make a mistake, it's either one of those two things. You either have an incomplete model of how it works and you need to update your model, or it's possible you misunderstood understood the question. You have a wrong assumption about what was being asked. So your intuition develops by being open to those exceptions or to the mistakes you're making and using those as opportunities to improve your model. And then the last thing is just that I think the game of chess is a really good job of teaching that complexity of math. So earlier I was talking about the electrical system of the car, but also the game of chess is a good example of that complexity because it has simple rules that create very complex positions. And there's all these strategies you can have in chess, but for every strategy, there's always an exception that breaks the rule in chess. So that's why there's supercomputers that play chess against each other all day, and there's all these positions that the supercomputers disagree on who's winning. So just like not every mathematical equation can be precisely solved, it's the supercomputers can't figure out which side is winning in certain chess positions. And it's that same complexity of numbers, which is why credit card encryption over the internet works. Without being able to use that complexity of numbers, we wouldn't be able to buy things over the internet. So it's pretty important to our economic system. And yeah, I did just want to go over those criticisms of math education. So I hope that kind of helps explain to everyone why I ended up stepping away in October. Thank you.